Good morning again. So, in continuation of last class, we have discussed about what is digital computer and back diagram of digital computer. Correct. So, students who are absent, as I told you in the beginning, please try to maintain old records and you should update the notebook while coming to next class. Compulsory use should come with updates. Don't ask I was absent because of that I don't know. Please, otherwise you are a loser. Already I told you. Now even we know block diagram of the digital computer. So what it contains? Block diagram of computer. What are the parts? So end user is going to provide input to the input devices. So the input output processor is going to consider your input and it will move to the CPU. Then from CPU it will be processed with help of RAM, random access memory. Based on that memory, it will be process your data. After processing, again it will come back to your input output processor. Then that input output processor is going to send output to the through output devices to the user. This is a block diagram. Whatever the computers we are using nowadays, this is the block diagram for all computers. Don't expect only laptop or CPU. In your mobile, whatever electronic device, it is a computer, digital computer. So whatever the device is using digits to evaluate the data, it is a digital computer. So it will be use same black diagram. And why you are sitting 6 members in a bench? Your first bench only 3 members. Is there a reason? You also. Why you are? It is not visible from there. Board is not visible. So, as per my understanding, you know your digital computer. Correct? Is it right? So, if you know the digital computer, because it is going to consider only the binary code as we are discussed in the last class, correct? Then how this binary code is manipulating? Because only we have discussed about it will be understand only binary code. Maybe it will be understand 1 or 0. 1 means high voltage, 0 means low voltage signal. So you know this. But 1 or 0 only one bit of information. But when we are giving input to the machine, it is a collection of bits. Yes or no? Yes or no? So every time when we are communicating machine, we have lot of data we are giving input. Then how machine is going to manipulate the stream of bits? So the machine or digital computer contains logic bits. Very important component in computer. Here the bits, whatever we are sharing, so the logic gates are going to manipulate your data, the stream of bytes. So basically we have 8 logic gates are there in a digital computer. Stand up. నిద్ర వస్తే నిల్చోవచ్చు లేదంటే పండుకోవచ్చు. సో వెనుకున్న వాళ్ళు కనబడట్లేదు, వెనుకలకి వెళ్ళి వెనుకున్న వాళ్ళ బోర్డు కనబడాలి కదా. యూ జస్ట్ గో అండ్ స్టాండ్ బ్యాక్ సైడ్. దట్ ఈస్ యువర్ రెస్పాన్సిబిలిటీ. మీకు నిద్ర వస్తే మీరు నిల్చోవచ్చు కదా, నేను చెప్పాలా? వీఆర్ ఆఫ్టర్ ఆల్ హ్యూమన్ బీయింగ్. సో ఎనీ వన్ విల్ గెట్ ఎనీ టైమ్ so that you can react accordingly. మీకు ఎందుకు నిద్ర వస్తుందో అడగట్లేదు, ప్లీజ్. సో ఇక్కడ ఉన్నాం, లాజిక్ గేట్స్. యా, సో లాజిక్ గేట్స్ ఆర్ a component in every digital computer. So through the logic gate, our data or maybe your digital data is going to stream. Because don't expect only 1, 0, 1 way passing. So whenever we are giving input, many lot of digits it will be transferred. So how machine, your processor is going to understand because of the logic gates. Very important thing. If you know this, then next chapters easily you can understand. This is the basic one. That is why I texted you yesterday night. But still students are not came. That is your fault. I cannot teach again this. Okay. Binary information. Speed fast. Binary information. Binary information is represented in digital computers by physical quantities called signals. Electrical signals such as voltages exist throughout the computer. Electrical signals such as voltages exist throughout the computer in either one of two recognizable states. Throughout the computer in either one of two recognizable states. What are those two recognizable states? 0 and 1. These are the recognizable states. You know already, just the technical definition, technical information I am giving. The two states represent a binary variable that can be equal to 0 or 1. మొత్తం సేమ్ రాయాలి ఏం లేదు కదా. Those two states are 1 or 0. How copy paste works you are doing? Just I am giving, just you write what you are understanding. For example, this example is required actually. For example, a particular digital computer may employ a signal of 3 volts. A particular digital computer may employ a signal of 3 volts represented by 1 and signal of 0.5 volts may be represent 0. As we discussed in the last class very clearly, high voltage of signal, it will be represented as a 1. Low voltage of signal, which machine is going to represent as a 0. Same. Just example I am giving. So that will be decided by the machine. Are you clear? So don't tell machine is going to understand zeros and ones. Only zeros and ones only machine is going to understand zeros and ones means again you are maybe not engineers. Yes or no? Binary language maybe it will fall, but not exactly your machine is going to understand 0 and 1. Correct? What machine is going to understand? High voltage signal, low voltage signal. It's an electronic device. It will accept only electrical power. Are you clear? So that how processor is understanding with help of logic gates. So Now coming to gates. Binary logic deals binary logic deals with binary variables, binary logic deals with binary variables and with operations. And with its operations. It is used to describe in algebraic or tabular form. Algebraic expressions and tabular form. You know tabular, you know. Algebraic expressions also, you know, right? Mathematics. So, algebraic and tabular form. The manipulation of binary information manipulation of binary information is done by logic circuits, is done by logic circuits called gates. Called gates. As I told you just now, your stream of binary data, how it is going to, binary data means stream of signals. How machine can understand. There is a one required circuit. Those circuits are called as gates. Are you clear? Yeah. Gates are blocks of hardware that produce signals of binary 1 or 0. Eight variety of logic gates are commonly used in digital computer systems. 8 types of logic gates are used in digital computer systems. Each gate has a distinct graphic symbol, and its operation can be described by algebraic expression. Means what you need to remember? 3 things. The first one is, whenever one gate you want to remember, what are the 3 components you should remember? First one, graphic representation of the gate. Second one, actually four, I will tell you. Second one is expression, your algebraic expression. Third one is tabular format of the gate, tabular information. These three things are very important, and operation. Fourth one is, otherwise, third one is the operation of that gate, and fourth one is the tabular format. These four things you should remember for every gate. Actually, it is very easy. Already you have done many things in your first year. Even electronic subject also you have done. Just only the representation and understanding is required. Then if you know the gates and the representations, it is very easy to understand this subject. Okay? Right. It is done. For, write down. For each gate, has one or two binary input variables. For each gate has one or two binary input variables designated by A or capital A or B. Input designated by A or B. Means your gate is having two inputs. So you can consider A or B. Only one input you can take A. Otherwise B. Okay. And for every gate, this is a common. And one binary output variable is designated by one binary output is designated by small x. So your binary gate is going to read two binary two inputs, please. The output is, after performing of the operation, the output is 1, that is representing through x. So first gate will go with AND. AND gate. So I have to write down the AND gate produces the AND logic function. The AND gate produces the AND. Always you should write capital A and D gates. AND logic function, that is the output is 1 if and that is the output is 1 if input A and input B are both equal to 1. Input A and input B are both equal to 1. Otherwise, the output is 0. So the output is 0. These conditions are also specified in the truth table for the AND gate. Okay. So what is the graphical symbol for this AND gate? So the graphical symbol is like D. So the input is as we told for every gate there is A and B, and output is X. This is a graphical symbol representation of your AND gate. So what is the algebraic function? So what is the output? X. How to write? X equals to A into A dot B. Or even you can write X equals to AB. As per the definition, when go with the truth table, what is the truth table? A, B, X. Correct. Then what is the truth table? When what is as per the condition? How? Whenever both ones, then only the output is 1. Remaining otherwise zeros. So 0, 0. Output is going to produce signal, low voltage, low voltage. This is the way you should understand. So output is low voltage only. So 0. Procedure is this. If your inputs to AND gate, low voltage, high voltage, the output is low voltage. Low voltage only for AND gate. So low voltage, high voltage, low voltage. మీరు ట్రూ ఫాల్స్ అని కూడా చెప్పుకోవచ్చు. ట్రూ ఫాల్స్ అవుట్పుట్ ఫాల్స్, 0 1 output 0, whatever you tell, but the machine understand voltages. That is why I am telling this way, but because you know already zeros and ones. Please try to understand subject to subject. Maybe the terminology is different. Okay, here we are not discussing about mathematics. Here we are discussing about the electronic device. So voltage, right? Then high voltage, low voltage, output is high voltage, high voltage. So true. The truth table, true or false. So this way you can understand truth table. Clear? So next one, R. So R gate. You can write AND gate already I given definition. Same you can write R gate. What will be happen? Any one input is 1, it will be written 1. Otherwise, it will return 0. Do it, right? Write out. This is the graphical representation of R gate. And what is the algebraic expression? X equals to, there is no other expression, only One way you can represent x equal to a plus b. Then coming to the truth table, now 0 0 0 0 1 1 1 0 1 1 1 1 1 2 1 or 2 1 1 1 1. So this is for OR gate. Correct? Done? Next, inverter. Third, inverter. And some people will call, actually, the textbook definition is inverter only, but people will call it different names. Not, or some people will tell it is a complement function. Result, it was inverter. Okay, you can call it as a complement function or maybe not. Clear? Then what it is? What is the definition for not gate? Inverse, reverse of the input. If input is 1, output is 0. If input is 0, here only it will be considered only one input. Yes or no? So the representation is like this. This is the representation. So A, what you will get? A dash. Correct. Nothing but this is X. What is the representation? X equal to A dash. Otherwise, it was both. ఏమొస్తుంది X కదా? సార్ input is A, output is X. What is X? X equal to A dash. Because we are following this structure. Otherwise, A dash also you can write, not a problem. We are following. So what is the truth table? A, output is X. Correct? 0 1 1 0. So all these gates we are going to use in future. That is why please remember this. Clear? Next, third one, fourth one. Buffer. Buffer nothing but there is no change. Buffering. You know, sometime you wanted to wait because some other work is going on, so that you don't want to stop the process and you don't want to continue the process because already the machine is already engaging with some work. Yes or no? So you should pass your data into buffer gate. So what will happen? It will take some time. It will take whatever input, it will produce same output. Then what do you use? Whenever you want to give some delay, because already your machine is engaging. Sir, no, with some, because your machine cannot perform multiple tasks at a time. It will be execute one by one. Yes or no? So like Q is one of the example. So first element is moving, next element should wait. Until that it will be in the queue only. You people are having operating system, the next semester you can understand. Because we need to manage everything. So in your mission hardware structure, buffer is there. Are you clear? Clear? So the thing is same. The representation is same like inverter, but there is no circle. This triangle symbol is there. There is no circle. So what is the algebraic expression? X equals to A. Got it? Got it? Buffering means the meaning of buffer you know. So sometime you want to wait that particular operation because already it is engaging by some other operation. So if you are not going to engage, what will happen? Maybe that instruction may be cancelled. So I don't want to cancel instructions of end user. I want to perform. That is my duty as a machine. Are you clear? So that your operating system is going to use all these gates. Just you link at the time of learning of operating system, you can understand the connection from operating system to computer organization and architecture. Clear? Now we are learning architecture, please. So what are the two tables? First you write 0, 0. Whatever it is, not a problem. Book will write always 0. Okay. Yeah. Next. NAND gate. ఎవరో మాట్లాడుతున్నారు వెనకాల. If you are having any doubt, you can ask me. Don't discuss unnecessarily. What is a NAND gate? Already you know. Tell me. Inverse of AND gate. Means, tell me, if I read 0, 0, what is the outcome? 1. If I read 0, 1, if I read 1, 0, 1, 1, means what is the formula, regular expression of the AND gate? X equal to AB old dash. Yes or no? So what is the representation? Same like AND gate you should write. Here small circle. Same AND gate structure only. Just you write on a small circle. So what is the formula? X equal to otherwise X equals to AB dash. Correct? Same. Just we are applying inverter of AND gate. So results also same. Now 0, 0. As per the AND gate, 0, 0. As per the AND gate, 0, 0. What is output? 0. Right? But 0, 0, 0. Yes or no? 0. Actually 0. But it is inverter. So that it will be converted 1. This way you should think. Then next, low voltage, high voltage. Actually it will be produced as per the AND gate, low voltage. But it is inverter of low voltage. Next, 1, 0. Then 1, 1. Actually high voltage, but inverter. Then got it. Shall I move to next slide? Next one, 6. NOR gate. Tell me, then you know. Huh? Inverter of OR gate. Correct? The representation is how it is. Same. First you write OR gate and add end with our circle, then X. Then what is the formula? Regular expression? Tell me. Generally, OR gate regular expression, tell me. Huh? X equals to generally A plus B. You should be apply. Okay. Then truth table A, B, X. 0, 0. For OR gate, actually, what will happen? 0. Only one case it will be true. Both, no. Both 0, only 0. Otherwise, all 1. It will be reverse. So 0, 0, actually 0. But next 1, 0, 1, 0. Don't confuse. First, you go with OR gate formula. OR gate formula is what? 1, 0. What is the outcome? OR gate formula? 1. Then inverse of 1, 0. This way you think. By heart, you have a panela. Please don't by heart the things. You should know and OR gate. You can do all the things. And not inverse. 3 things you should require to generate remaining gates. These 8 gates are predefined gates. Are you clear? From these 8 gates, you are going to create new gates as per your logic. Are you clear? So I will give some expressions you should design. So I will show you 1 or 2 samples. Are you clear? So 0, 1. Actually 1, then it will be 0. 1, 1. Got it? Yeah, please. Next, exclusive OR. Exclusive OR. OR will be called as XOR. XOR. Do you know this? You don't know. I will tell you. Just write down. Exclusive OR. The output of this exclusive OR gate, just you write down one statement, you can understand. The output of this exclusive OR gate is 1. If any input is 1, but excludes the combination, when both inputs are 1. So I will show you the representation. Exclusive OR. Same like you write. But here one more line you should write. Line. So if you remember even the regular expression of algebraic expression also you can remember. X equals to A XOR of B. Otherwise you can write A equals to A dash B plus AB dash. If you remember this expression, you can solve the problem. Are you clear? This is the main point you should remember for expression, regular expression for the exclusive OR, XOR. A dash B, it will be produced A dash B plus AB dash. Then you can solve the problem easily. And you should understand this in future gates also. If you want to generate new gate also, you can solve the thing. Got it? How to connect, what to connect. For example, coming with this truth table, now tell me, now 0, 0. Then what is the output? First, when you read 0 from here and B 0, right? Output is X. What is X now? A dash B. What is A dash? 0 dash 1. What is B? 0. 1 0. How much? 1 0. AND gate. ఇక్కడ అండి ఇక్కడ అండ్ కదండి ఏ డాష్ డాట్ పెట్టుకోండి క్లియర్ ఏ వాట్ ఈస్ ఏ 0 వాట్ ఈస్ బి డాష్ 1 0 అండ్ 1 0 ఇక్కడ ఏమొచ్చింది 0 0 ఆర్ 0 వాట్ ఇస్ ద అవుట్కమ్ that is what I told you. Remember this algebraic expression so you can solve for especially exclusive OR and exclusive AND gates. Are you clear? Clear? Then now tell me Chapan, any doubt? Any doubt? 0 and 1 combination. 0 means 1 1 0 1 0 how much 0 నేను మిమ్మల్ని నమ్మను అయితే నేను చేస్తాను సో ఏ 0 ఏ డాష్ 1 1 into what is B 1 1 1 1 right now A how much 0 B dash 0 1 or 0. Are you clear? If you understand this, in future combination of different gates you can understand. Clear? Next. 1 0. Maybe you will get one only. Just AB dash plus A dash B. Anta avutundi kada. Next. 1 1. 100% 0. Why? You reverse this. That way also you can remember 0 0 means 0. Then 1 means yes or no? Check mali big doubt unte. A dash 0, B 1, 0 1 0. A 1, B dash 0, 0 1 0, 0 or 0 0. Got it? ప్లీజ్ మీరు కాపీ చేయకండి వీలైతే టచ్ చేసి రాయండి నెక్స్ట్ 8th one ఎక్స్క్లూజివ్ నార్ sometimes it is called as equivalence okay so the representation is exactly reverse of XOR clear what extra you will get this is the graphical representation exactly the circle is extra to the output got it then what is the formula same exactly ఏమొస్తుంది కాంప్లిమెంట్ వస్తుంది కదా అదే మరి ఫార్ములా x ఈక్వల్ టు A XOR B complement correct then R how to write x equals to ఎలా వస్తుంది కాంప్లిమెంట్ అంటే ఎలా వస్తుంది AB డాష్ ప్లస్ A డాష్ అంతేనా రాంగ్ అట్లా రాదు A dash, B dash plus, you should remember this. You should remember exclusive OR for this expression and exclusive NOR for this expression. So that you can solve the problem. A dash B dash plus AB. So you can generate your truth table. Now tell me, 0, 0, 1. Why? 0 dash, 0 dash, 1, 1, 1. Then AB, 0. 1 or 0. Then 0, 1. 0 dash means 1. 1 dash means 0. 1, 0, 0. Plus 0, 1. How much? 0 or 1? 1. 1 or 0 na? 0. 0 plus 0? 0. I think you will get same. 1. Then 1, 1. Hey, 1 వస్తుంది అనుకుంటా చూడు. ఇక్కడ 1 వచ్చిందంటే ఇక్కడ 0 వచ్చినా పర్లేదు కదా. సింపుల్ లాజిక్. AB you check. 1 is there. As per the R logic, AB combination you check. Easy చేయాలనుకుంటే AB combination you check. AB is 1 means 1. Simple. AB 0 means maybe you check A dash B dash. Got it? Because it is R. Plus is R. So it is 1. Clear? Clear? Any doubt? So these are the logic gates. If it is clear, we'll go for next advanced things. Shall we? Yeah. So report task repe untadi. Boolean algebra. So next topic is Boolean algebra. Now somehow you understand how to write expression for 8 gates, right? From gates, the logic only we have developed truth table. Yes or no? So now these are the basic 8 gates. From these basic 8 gates, we can construct the circuit, logic circuit based on the expression. Are you here? So the expression is called as Boolean expression. Boolean algebra is an algebra that deals with binary variables and logic operations. Deals with binary variables and logic operations. What is binary variables? What is binary variables? Your inputs are binary variables, not binary values, binary variables. You are taking inputs, right? A is one input or B is another input. Are you following? Just inline with previous topic. You can understand. Don't read separate way of our subject. Continuity is required. If you are going to attend next class without this knowledge, maybe you are in a trouble. Please. A or B. Now, what is binary logic operations? Logical operations, logical gates, you know, and are not. Are you clear? exclusive or buffer we cannot use much. Okay, these are all the operation. How to construct these logic is nothing but a Boolean algebra. Got it? Got it? So anyway, we'll continue tomorrow. Just I am giving the idea, the topic, what we are going to discuss. So I will give one example for Boolean algebra, how to construct a logic circuit based on these 8 logic gates. Then I will give some assignment to you. Then you should construct a logic circuit. So that is very important. If you know this, then you can understand how your machine is going to evaluate your digital data by your why is it digital computer? Because it is going to evaluate digital data with help of your logic circuits. Clear? Got it? Okay. Is that stop and